أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Moderation Analysis IBM SPSS AMOS series. In this session, we are going to look into moderation analysis. Although we have previously looked into how to perform moderation in AMOS, but that was primarily based on path analysis, where we used composite variables. Now, the previous examples describe how to test moderation in a path model or specifically with composite variables. What if you want to test moderation in a full structural model? Now, there are three different ways to test moderation in a full structural model. Now, these three ways are the mixed model method, the full indicator interaction method, and the matched pair method. For this video, the focus will be on the mixed model method. Now, each method has advantages and disadvantages in assessing moderation. First, let's talk about mixed method. Again, the first step, as we have done earlier, it is find the mean values for your IV and moderating variable and mean center them. How do you mean center them? Create a mean centered variable in SPSS, go to transform, click compute variable, and for CC, that is your composite variable that you got by taking the mean of all the indicators of that particular variable, then subtract the mean from the variable. Go to transform, compute variable, and it does it for each of the mean value that you get for a particular respondent. And once that is done, you have to do it the same thing for RA minus the mean value. Now these variables are mean centered. Your independent variable, collaborative culture, your role ambiguity, both are mean centered. A detailed video on mean centering that I did earlier will be shared as well. Now you have to create the interaction term. How do you create the interaction term of the mean centered variables? Again, go to transform, compute variable, give this name interaction, CC into RA, and the centered variable center CC into RA. This will create the interaction term, because based on the interaction term, our moderation is analyzed. Once this is done, once the mean centering is complete, let's talk about mixed model method. The mixed model method includes the latent unobservable variables with the independent and dependent variables in a model, but they include composite moderator variable along with the composite interaction term, just as we did earlier here. We created a composite interaction term with composite, independent, and moderator. So you multiplied both of them, you got your interaction term. That was composite. And then you've got composite scores for your role ambiguity, that is your moderator. Now this is not a true test of full structural model, because you have both latent unobservable constructs and composite variables included in the same model. So this is not the true full structural model, because you've got composites as well, and then you've got unobserved latent variables. The variables of collaborative culture and organizational performance, that is your independent variable and dependent variable, are latent unobserved constructs with all indicators included. I'm just going to show you how it works. The moderator role conflict is a composite variable found by the average of the moderator indicators. Now the indicators are averaged, and then you get your composite variable of role conflict. To get the interaction term, you simply form the composite variable of the independent variable of collaborative culture as well. So, and then obviously you multiply both of them, that is your role conflict and your composite variable, collaborative culture, but both should be mean centered first. Now let's do some model comparison. Now this was the earlier model that we did earlier, all composite variables, interaction, moderator, independent, dependent. Now this is a mixed method model. Your independent variable, that is your latent unobserved variables with its indicators, your dependent variable with its indicators, but your role ambiguity, that is your moderator, is a composite variable, and your interaction is composite as well. Now moving on, let's analyze the results. These on the left side of your screen, the results are from the previous model that is based on composites. You will notice in the estimates link that the relationship from CC to OP is slightly different. Now look at this. This here on the right side is your model. This one, this model here on the right side, and this is your old model. And look at this. There is difference in your estimates. The estimates are different. This one slightly weakened, but these weakened, and this one is improved. The relationship from independent variable to the dependent variable is including the measurement error of the indicators. So you've got the indicators from IV to DV. That's why it is giving more accurate estimation. The results of the interaction term, that is this here, to the dependent variable OP have now weakened here. They have weakened, although it is still significant. So RA is moderating the relationship between collaborative culture and organizational performance. While this is not a true test of full structural model because of the mix of latent and composite variables, this approach can still provide an accurate examination of how a moderator can influence the relationships between latent constructs. Now, the next step after this is probing the interaction, but let's first do this model here. So I've got this. These are my variable. This is my data. So this is the interaction between collaborative culture and role ambiguity. This is your centered role ambiguity, centered collaborative culture. So I multiplied both of them to get this particular variable. This is your interaction of CC with RA. Now let's do this model first here. So once you import your data, let me do it again just to clarify. Yes, this is the data. Press OK. Now, once your model is done, I've already done it. You simply need to add the variables from here. Let's say this is your interaction CC into RA and your centered RA here. Now this is your mixed model for moderation, whereby you've got latent unobserved variable with its indicators, then your dependent variable and its indicators, and the moderator variable that is composite, and your interaction term based on the mean value of CC and RA, both mean centered and then multiplied. Again, this is your data, and look at this. For each individual respondent, you will calculate the mean first for your variables like this, CC, RA, and then you mean center them just as I did earlier. Just simply subtract the mean from CC and you will have then the centered variables. You will use transform and compute variables option. This is your centered collaborative culture for each respondent, and then similarly for role ambiguity. The next step, you multiply them to create interaction. Again, you do it through compute variable. Now let's run the model. Look at the estimates. Now if you look at the estimates here, the interaction term is significant. Here 0.011, and this shows that role ambiguity moderates the relationship between collaborative culture and organizational performance. Your impact from role ambiguity to organizational performance is also significant. All three results are significant. Now that I know that my interaction effect is significant, that is, role ambiguity is moderating the relationship between collaborative culture and organizational performance, the next step is to probe the interaction. See if this moderating effect changes with high and low values of role ambiguity. Now how do we do this? Simply, we have done it previously. The same procedure is to be used. The video will be shared in the description, but I'm going to quickly go through it as well. To probe the interaction using this method, you would need to form a new composite moderator that represented the low and high values of the construct. Mean-centered composite moderator plus or minus 1 standard deviation. So what you need to do is to create high and low values of the moderator and see whether it moderates the relationship we need to have our standard deviation value, and then that standard deviation value added or subtracted from the mean-centered composite moderator. You would then need to create a new composite interaction just the way we have done it earlier. We mean-centered the variables and we created the interaction term. Again, we just need to add or subtract standard deviation values to have high and low values of the moderator. And then what you need to do is just create the interaction term. How to do this, how to probe the interaction, let's look at it quickly. The earlier video will also be shared in the description. Now step 1. In our moderation example, we can see that the interaction is significant and negative, but we do not know much else about the interaction or ultimately how the moderator influences the relationship from the independent variable to the dependent variable. Next, we can probe the interaction, which means we are going to explore how the relationship from independent variable to the dependent variable changes at different levels of the moderator. At the high level of the moderator, what is the relationship? At low level of the moderator, how is the relationship? Now, to accomplish this testing at different levels of the moderator, we are initially going to explore how to examine a moderator at low levels. Now, by creating a new low level moderator variable. And what we need to do for this is that this is one standard deviation below the mean of the original moderator. So that is one standard deviation below the mean. So how do we go for one standard deviation below the mean? Conversely, we are going to create high-level moderator test in which we examine the moderator at one standard deviation above the mean, that is mean plus one standard deviation. Low, mean minus one standard deviation, and high, mean plus one standard deviation. The first step is to find the standard deviation of your moderator, which is 1.36595. You simply go to Analyze, Descriptive Statistics, and therein you will find your variables. Just add them and find in your standard deviation 1.36595. Now let's probe the interaction when the moderator is low. Let's find out how your relationship changes when your moderator is low. We need to form a new variable in the dataset that represents moderator at low level. Let's call the new variable low RA, that is low level of role ambiguity. So what we need to do is in the transform menu in SPSS, we go to compute variable function. So what we need to do is, I'm just going to quickly do it as well. Go to transform, compute variable. Let's name it low role ambiguity. And how do you create low role ambiguity? Have a look here. We label our new construct and then take the mean centered composite variable, the variable that you already centered, and add the standard deviation. When you are creating low RA, you need to add the standard deviation. Now, it does seem odd to get low moderator value by adding the standard deviation, but this is necessary process to represent the low levels of the moderator, since the standard deviation further from the mean would be low role ambiguity. So if you're going away from the mean, that is by adding the standard deviation, you are going away from the mean. Below the mean would mean distanced from the mean, and this will mean low role ambiguity. So you are going away from the mean rather than coming closer to mean. That's why when you are looking for your low role ambiguity, that is low level of the moderator, you add the standard deviation. This means that you are going away from the mean value. So what you need to do is, where is your centered RA? Here it is, shift plus 1.36595. I hope the value is correct. You simply press OK. Your new value will be created. Let's use this now. Again, we didn't create the interaction term. So how do we create the interaction term? Again, your centered variable, that is your independent variable, multiplied by the newly created low role ambiguity. And once you have done it, we are going to add it into the model as well. So how to do this? Transform, compute variable, and let's name it interaction CC into low RA. So interaction CC into low RA. So I want to find out how the relationship changes at low level of role ambiguity. So you'd have to create the interaction term just as we did in earlier videos, or earlier we created the interaction as well. So where is your CC? The centered CC. Here is your centered CC, and here is your RA multiplied by low level of role ambiguity. And now you've got inter CC into low RA here, this one here. This was inter CC into average level of role ambiguity, and this is low role ambiguity. Now again, we are going to later use the same process, but we are now going to subtract the standard deviation to bring the value closer to the mean when we are doing high RA. So in this case, this checks out, everything checks out, press OK, yes, and now let's go to AMOS. Here is AMOS. I'm going to add the variables now. Come here, variable list, here it is. So low RA and the interaction of collaborative culture with low RA. And now simply run the model and you will have your analysis here. Let's look at this. Estimates. So if you look here at low role ambiguity, look at the effects. It weakens significantly because your p-value is 0.000. Previously it was 0.011. So the impact at low role ambiguity, the impact of CC on OP has improved. Now let's move back and let's go on. Now this is already done. Look at this. Again, we have already interpreted it. Your impact of collaborative culture on organizational performance at low level of role ambiguity, it's significant, and the impact has further improved this particular relationship. In the output, the only relationship we are concerned is that of CC to OP. This is the one. So we want to see how this relationship changes when the low RA is included and this relationship has strengthened. The results show that when an employee had a low degree of role ambiguity, the relationship from CC to OP is significant and stronger. The original test had an unstandardized regression weight of 0.553 and it has increased to 0.813. Now let's go for higher levels of RA. Again, I'm not going to repeat it. It's been done with low RA. What you need to do is create a new variable by going into transform compute variable, type in high RA, and from the centered variable just subtract. Why am I subtracting it? Because you want to bring the value closer to the mean. So it's higher role ambiguity. Previously we add it. And then we create the interaction term. That is interaction between CC, that is your IV, and this is your moderator, and this is the interaction, the centered collaborative culture with high role ambiguity. And now we are going to add this to our model in AMOS. Similarly, let's go to input here. High RA, just the way we created low RA, we have now high RA, and interaction effect, just the way we had previously. Now again, you simply run the analysis and you will have the output. And look at this, at higher RA, the relationship is weakened. And at high RA, your moderating effect is not there. There is no moderating effect. Let's go back here. The moderator is significant at low and average level. That is here, low level, significant. Average level, significant. That is the moderating effect. But at high level, the moderating effect is insignificant. So your moderating variable is not moderating the relationship between CC and OP when it is high. Hence, the construct of RA is moderating the relationship of CC to OP. Now by probing the interaction, you get a better picture of the relationship between the independent variable to the dependent variable in presence of the moderator. Moving on. Mixed method or path analysis, which one shall we use? The path model is the simplest way to test moderation, but you are not assessing any of the measurement error in the model. With this method and the path model in near saturation, which can skew model fit results. The mixed method approach accounts for measurement error in the independent and dependent variables, but actually fails to do it for the latent interaction test and subsequently does not account for measurement error in the moderator. With each method having its drawbacks, but based on the analysis, the advised approach to moderation testing would be mixed method or another method, that is matched pair method, that we are going to do later. Moderation analysis results. Now how do you interpret and report the results finally? So here is a table that one can present. Here is the slope. How did we get the slope? I'm just going to talk about it. First, let's look at the description of results. How to report it. The study assessed the moderating role of role ambiguity on the relationship between collaborative culture and organizational performance. The results revealed a negative and significant moderating impact of RA on the relationship between CC and OP. Is it significant? Yes, it's significant. That is, your hypothesis is supported, and results are presented in this table here. Now, results of simple slope analysis conducted to better understand the nature of the moderating effects that are shown in figure 1. As can be seen in the figure 1, the line is much steeper for low roll ambiguity. Look at the low roll ambiguity blue line. It is much steeper in comparison to high roll ambiguity. This shows that at low roll ambiguity, the impact of CC on OP is much stronger in comparison to high RA. That is, if you increase your collaborative culture, there is an improvement in organizational performance. But at high RA, even if you are increasing your collaborative culture, this does not lead to a similar sort of increase in organizational performance. So the impact of CC on OP is much stronger in comparison to high RA at low RA. As shown in figure 2, as the level of RA is increased, that is high RA, the red line, the strength of relationship between CC and OP is decreased. At low roll ambiguity, it is much stronger. How did I get this graph? I used the James Gaskin stats tool package. The link will be shared in the description. This is my independent variable, roll ambiguity OP. What is this? Independent variable. The impact of independent variable on the dependent variable at mean level. So where are my mean level results? Here they are. Here they are, mean level results. 0.553, 0.076, 0.159. 0.553 moderator, 0.159 with a negative sign. 0.159 moderator, and the moderating effect 0.076 with a negative sign. 0.076 with a negative sign, and this is the graph I got, and this is how I interpreted it and reported it. Finally, if you want to know more, this is a very good read. Thank you very much.